Welcome to Lab 8. This is for thermochemistry. And part 1 of this lab is going to be exo and endothermic reaction determination. We're going to do 2 reactions. One is acetic acid plus sodium bicarbonate yields carbon dioxide and sodium acetate. And the second one is magnesium plus acetic acid yields hydrogen gas and magnesium acetate. All right, now you should remember both of these. The first one, acetic acid plus sodium bicarbonate, NaHCO3, that's just baking soda and vinegar. And the second one, an acid plus magnesium, that's a redox reaction from chapter 4. All right, so now let's go ahead and we're going to go along with this. The first thing that I want to draw your attention to is right here there was a typo in this lab, and instead of measuring out 1 gram, we're going to be measuring out 0.10 grams of our magnesium metal. Okay, so first of all, we have 10 grams of baking soda and 100 grams of vinegar. Now, the vinegar is acetic acid in water. Okay, and that is the volume of the mass of our surroundings. So hopefully you've read the material for this week about system versus surroundings and about specific heat and Q. If you have not, you're not ready to do this. I'm not going to be explaining all of that in the lab. So if you haven't yet taken notes on this chapter, then before doing this lab, you need to go and take notes on the chapter. All right, so let's look at our first one, the part A, baking soda. So we're going to begin by measuring out 100 grams of our vinegar. All right, and we're going to call that good. So that's 99.7. All right, I don't have the materials to get closer than that. Okay, so I'm going to go ahead and come over here, and I'm going to be making a note here that for this one, that the mass of my vinegar is actually 99.7 grams, and you're going to need that when you're doing the specific heat SM mass delta T. Okay, so that's the actual mass of our vinegar. Now I'm going to put this in here to make sure that it's stable. And I'm going to put my temperature probe into it. And we're going to go ahead and let it equilibrate just for a bit here. Now the second part is we need to measure out 10 grams of baking soda. So on my scale, I'm going to put a little measuring cup, and then I'm going to tare it. I'm going to bring it to 0, and I'm going to attempt to measure out, here I have my baking soda, 10 grams of the baking soda. Let's see if I can do this without making a mess. All right, that's 1.6. And 3.1. 4.8. 6.6. This is going to be a lot of baking soda. 7.3, 8.7, 10.8. So I'm going to try to take a little bit out because I want to actually try to get this as close to 10 as possible. All right, there we go. And I got my baking soda exactly to 10. So So I'm going to come over here and I'm going to put in the mass of my baking soda equal to exactly 10 grams. Okay, and just remember that vinegar is acetic acid, HC2H3O2, and water, and baking soda is NaHCO3. All right, so now let's go ahead and I'm going to turn off my little scale and we're going to get our initial temperature. So right now, here I have my temperature probe and my vinegar, and it says that my T1 here is 19.7 degrees. Okay, so I'm going to come over here where it says initial temperature, and I'm going to put in 19.7 degrees Celsius. Okay, and now we're going to do all the rest of this in order to get temperature. Okay, all right, so I'm watching this. Now, one thing that I've learned over time is that if I don't add this slowly, I will make a mess and I will lose some of it and it will not be good at all. So, and as this reaction is beginning, we can't do it too slowly, but you can see that the temperature is starting to go down. Now this part 1 is actually the exact same lab basically that you would be doing in the lab if you had a real lab right now, except that you would be doing this not with vinegar but with actual other acids. The first part is, I think, usually done with citric acid, and then the second part is done with hydrochloric acid. But I'm not going to use dangerous chemicals like that in my house. Oh, now I can see, oh, I added a little bit more there, and very nice and vigorous reaction, and I can see that my temperature is really starting to come down. And basically, again, just to review, that means that the reaction between the vinegar and the baking soda is pulling heat from the water that the vinegar is in order to do that. So this temperature change that we're seeing as we see the temperature decrease means that our system is removing heat from our surroundings, okay? So what we're actually going to be doing at the beginning of this is we will be looking at, specifically, we're going to be looking at the temperature of the water surrounding our system, which means we're looking at the temperature of our surroundings. So we'll be calculating Q, or heat, for the surroundings. And you'll notice that one of these boxes says heat of system equals Q reaction. Heat of system is Q reaction equal to the opposite, or the negative, of Q water. And that's where you'll change it so that your sign reflects your system. And you would get a much more dramatic reaction in the lab. Again, vinegar is a fairly weak acid. Okay, and now we're going to go ahead and we're going to let this continue until the reaction has finished all together. and our temperature has stabilized. Okay. So this is right down around 12.5 degrees Celsius. Okay. So we will come over here and we will put in 12.5 degrees Celsius, and that is our final temperature. Okay, and I will let you guys continue this. Again, if you're not quite sure how to look through this, I would go take a look at some of the parts of the material itself. All right, now we're going to go on to part B of part 1, and that's with the magnesium. Okay, so what I'm going to do for a moment here is I have, this is cold water, it's not really room temperature because I just took it out of my tap, but I'm going to go ahead and put my temperature probe in there. Okay, and that's just basically to wash my temperature probe from whatever was in it. And we'll start this again, and this time though we'll start this with magnesium. Okay, so I have my little scale here again. Okay, and into this I will be pouring some more vinegar. So I'm just gonna zero this out with the styrofoam cup on it. And if anybody's curious, these are actual styrofoam cups from work because I don't have styrofoam in my house. And the interesting thing is that these styrofoam cups are the same styrofoam cups that we have used for this lab for the last 16 years. We save them and we do not waste them. All right, so I'm going to be pouring out 100 grams of my vinegar again. All right, and again, that's where I'm going to be for this. And this vinegar reading is 99.8 grams. So I will go ahead and put that here. Mass vinegar equal to 99.8 grams. And then we'll have the mass of our magnesium. And as I said, that there was that typo, so we're going to be aiming for 0.1 grams of our magnesium. Okay. Oh, I should have uncapped this. All right, hold on just a moment. There we go. Okay, I had to set that down because I only have 2 hands. All right, so now I need to find 0.1 grams, and that's because the heat, the specific heat for this is different. Okay, well, I forgot that this scale doesn't do 0.1 grams. This scale does 0.2 grams. So we're going to go ahead and go with 0.2 grams. Okay, so here is the mass that you're using here, 0.2 grams. And this one won't be super exact because I don't have great significant figures available with this. All right, so here we go. We're going to bring this over here. And we're going to start this again. All right, so I take my clean temperature probe and put it into my vinegar that's been sitting at room temp. And trying to move things around off camera without making a big mess. I'll kind of let the temperature probe equilibrate. We had been at 19.7 before, and we have reached 19.7 again, which is good. Just means that the house is pretty stable there. Okay, so our initial temperature, again, here we're looking at our surroundings, 19.7 degrees Celsius. Okay, and now what I'm going to do is I'm going to, here, I'll move this closer so that you can continue to see both of them. And let's see what happens when we add magnesium. And it's just a little bit of magnesium. And that I'm going to add all at once, because that won't bubble over. And this might take a minute. You can probably see in there through the bubbles, which are hydrogen gas. And this isn't quite as drastic. In how much it will change. I can kind of still, I can feel the bits of magnesium shaving in there still. Sorry, I know that this is terribly dull. It's much more interesting to do in the lab, where you can be watching this yourself. When this is done with hydrochloric acid, which again I'm not using in my kitchen, it's a much more interesting, it's a much more rapid reaction, because hydrochloric acid is a very strong acid, and vinegar is a weak acid, so you have to wait a little longer for the reaction to get to completion. And I can see that there's still some shavings. If I wait, I can see them rising to the surface a little bit. See if I can. You can sort of see them a little bit on the camera. Maybe not. I can see them. It's too bad you can't see this. It's actually, well, you would have seen it in the Chapter 4 labs, but it's actually a fairly aggressive reaction. It's just that the camera doesn't pick it up. So there's quite a bit of hydrogen gas coming out. You can see a lot of bubbles. The bubbles are so active that it's that every now and then a piece of magnesium shaving will float to the surface and then disappear again as it sinks. See, there's one there. And it's actually floating on top of the bubbles. There's so many of the bubbles there that the magnesium rises to the surface, held up by the bubbles before it sinks again. And again, this reaction, it's a little slower. It only takes 2 or 3 minutes in the lab. I probably should have taken my initial temperatures and done these at the same time. So my apologies for that. You can see the reaction, the hydrogen bubbles pushing those shavings to the top again here. And we're up to 23. Oh, we're starting to go up pretty quickly now. So the reaction is really getting going. So we went down about 7.2 degrees with the baking soda. We have already gone up almost 4 degrees. Well, 3.5 degrees with significantly less magnesium. So it tells you a little something about the mass that's kept behind. All right. So now we can see this temperature is going up. And again, we are taking the temperature of the aqueous vinegar solution. So we're taking the temperature of the water. And that again is an example of taking the temperature of the surroundings. So once we calculate our Q, or our heat change for our water, then what we're going to be looking at with that is we calculate that we have to reverse that, because the temperature of our water, the Q of our water, is equal to the opposite, or the negative, of the Q of the reaction. So you just have to switch the sign. And I'm surprised that I should have started with new vinegar. I think that it would have been a bit stronger, but this is the same vinegar that I used at the beginning of the semester. We're up to 24 degrees Celsius. What you're seeing here is the same kind of technology, not this exact thing, but the same kind of technology that works for cold packs and hot packs. For example, if you have a cold pack for the ones that you put on like a sprain or something like that, you can buy the packs and you crush them together, and as you crush them together, they become that. All right, I am going to, you guys are just watching this, so I'm actually going to upload a picture when this is complete, okay? And I will take a photograph, I think. Well, actually it's almost done, I think. See, shavings are getting very small. If I'm patient for just another moment or two. Agitating, which is just stirring, but agitating tends to increase the reaction rate. If you go on to Chem 2, one of the things that you'll study is chemical kinetics, and that's the study of reaction rates. Well, there are still quite a few shavings in here. I apologize for it taking so long. All right, I will put a note in the comments about the final temperature, since this is going on so long. So if you've watched to the end, please wait, and when you're done with this, you'll be able to put in the final temperature.